Hi guys, let's take a look at this question. We have a group of learners that prepares a 0.25 mole decimeters per cubed solution of sodium carbonate by dissolving a 14.2 gram sample of hydrated sodium carbonate into a 200 centimeters cube of water. I see that in one breath. 7.1. Explain the meaning of the term hydrated. So hydrated means to be surrounded by water molecules. 7.2. Write down a balanced chemical equation to show how sodium dissociates in water. So we have, sodium carbonate. So we have sodium carbonate, right? That's given there. How does it dissociate in water? So it will dissociate by having the sodium plus the carbon, right? So, do you think that is balanced? Right? Okay, so we check. There's two sodiums, but there's only one, so we added two in the front here. There's one carbon cool. There's three oxygens, and now it is balanced. You can put your positive charges if you want. You can put a positive charge there because sodium is a positive charge, and oxygen is negative charge, -2. I'll just show you again. So sodium is +1, oxygen will be -2. So just study the charges. I don't think they'll give it to you in the exam, so just study them. So therefore we can put -2 at the top. So that's a balanced chemical equation. 7.3. Learners then take the 10 centimeters cube of the prepared solution and allows it to react completely with the 5 centimeters cube of dilute hydrochloric acid according to the following balancing or balanced chemical equation. Define the term a mole of a substance. So a mole of a substance is the amount of a substance having the same number of particles as there are atoms in 12 grams carbon 12. 7.3.2. What type of chemical reaction is represented by the chemical equation above? That is called an acid-base chemical reaction. 7.3.3. Calculate the number of moles of hydrochloric acid in 5 centimeters cube of hydrochloric acid if the concentration is 1 mole. Okay, so we can just use our formula C equals to N over V. We have the N, which is 1. We don't have the number of moles, but they have given us the volume, which is 5 centimeters cubed. We want meters. So we are going to divide to get 0,005 and we multiply to get 0,005 because we're multiplying by 1, so that is moles. Then last one, 7.4. Calculate the mass of sodium chloride formed in this reaction, 7.3. Okay, so we have now, 7.4, right? So we have the number of moles. We are looking for the number of moles of sodium chloride, and we have the number of moles of hydrogen chloride, right? Which is that we had just been given as 0,05. But if you look in the balanced equation, if you look at sodium chloride formed here, that's 2 and 2, which is essentially 1 and 1. So they have to be the same. So 0,005 and 0,005. So the number of moles of sodium chloride is 0,005. But they want the mass, right? But now we can comfortably jot that into our formula. We have the 0,005. We don't have the mass because that's what we're looking for, but we can get the the molar mass of sodium chloride. So we have sodium and we have chloride. So sodium atomic mass is 23 and chloride is 35,5. So we add that together and we get 58,5. And we multiply to get the mass to be 0,29 grams. Cool. And that is it, guys. See ya.